Hi there. For this video, we're kind of transitioning to talking about circles and parts of circles. So, um, central angles of circles, arcs of circles, and we're going to talk about finding circumferences as well. So our goal for today is to find circumferences and measures of central angles and arcs. And the arcs and they all kind of connect to each other. So let's start off with what right here. A circle. A circle is basically the set of all points in a plane that are equidistant from a given point, called the center. So if you have your center, I don't know if you ever thought about this, but every point on the circle is exactly the same distance away. Obviously, if you draw a better circle than that. A circle is named by its center, so that's important. So whatever the point in the center is, that's what the circle would be named. So if this is C, this is circle C. So looking at this diagram kind of helps break down a couple of things for us. P is the center. Um, if you look at this angle, this would be a central angle. Any angle coming from the center would be a central angle. So this is also a central angle. This is also a central angle. They're all central angles. AB is the diameter, and PC, which is half of, or A, or PB, or PA, those are all radiuses. Say PB, say PA. All radiuses are half of the diameter. The diameter is a segment that contains the center and has both endpoints on the circle itself. Whereas the radius is a segment that has one endpoint at the center and one at the outside of the circle. So it's half of a diameter. Moving on, a couple other basics. Congruent circles are circles that have congruent areas and circumferences. You also have congruent diameters. You have congruent radii. A central angle we talked about is an angle whose vertex is the center of a circle. So looking at this, a couple other things. So segment TR is the diameter, and a semicircle is half of a circle. Example, when we're dealing with arcs, we're going to say this would be TSR. So a semicircle is the arc that's half the circle. A minor arc is something that's smaller than half the circle. And the major arc would be something that's larger than half a circle. So examples of a minor arc would just be like arc RS. So minor arcs, you just need to have 2 points in the labeling of it. Anything that's a half circle or greater would have to have 3. So you kind of know the direction. So for a major arc, I could say this blue one, STR. And you know T is in the middle, so it has to go in that order, STR. Because if you put it in a different order, if you did TSR, that would be a semicircle. Or RST would be the same idea. And finally, a chord. A chord is a segment whose endpoints are on the circle. So technically a diameter is a chord, but you'd call it a diameter. Anything else, so here's an example in red. Going from here to here, that is a chord. So these are things we're dealing with in these next couple of sections. Um, and just a tiny little bit about arcs again. Arcs or central angles. So this is really actually important. This is kind of the basis of a lot of what we're doing today. The arc measure. The measure of a minor arc is equal to the measure of its corresponding central angle. So if this central angle is 50 degrees, the arc measure is also 50 degrees. So arc measures go by the degrees of the central angles. The measure of the major arc is the measure of the related minor arc subtracted from 360. So um, this arc, again, right here would be 310 because it would be whatever's left on that circle. Because the whole circle makes 360 degrees. Adjacent arcs are arcs of the same circle that have um, 1 point in common. I don't know what's supposed to get in here right now. I think it's just supposed to... So we'll say exactly 1 point in common. Because you can't have more than 1 point in common. Adjacent are right next to each other, 1 point in common. So let's do some examples with all that stuff we just talked about. Let's start with naming arcs. We kind of talked about that briefly. What are the minor arcs of circle O? So let's try to name as many of them. Remember, they're less than half the circle. So AD or DA would be the same thing. AC, CE, again, you don't have to rewrite them backwards. DE, or ED. I believe that's it. Semicircles go around half of it, so semicircles we're going to use DAC as one. ACE, CED, and then arc EDA. So anytime you have a diameter, you can make a semicircle, two semicircles from that. So it's cutting the circle in half, causing two semicircles. And that leaves any major arcs that we can find that are greater than a semicircle. So let's look at these. I can find D. So this one would be one. You don't have to list all 4 points that are there. You just have to have three. So you could say that would be DAE or DCE. Either way would work, or you could go backwards. So I'm going to say DAE or DAE. You could do CEA. Um, you could do all the way around here, which is in green, DEA. And you could do the other way too. You could do ACD or AED. And I think that's it, but you can keep naming them if there are more, but you have to be greater than a semicircle. All right, let's look at the circle to the right. Number 4 says name two chords of circle K. So chords are something that has two endpoints on the circle. So technically, segment AL is a chord, but we're going to call it a diameter. And then you can also say segment NO. Nope. It says if AL is 9.4 whatever units, find KD. So you might say, how does that have anything to do with it? But if this is a diameter, this is the longest chord on a circle. And this right here is a radius. So that would, radii are half of a diameter. So KD is going to be equal to 1/2 of 9.4, which is going to be 4.7. Last question, is segment NO less than segment AL? Yes, it has to be, because diameters are the longest chords. And anything that's not a diameter would have to be shorter. All right. All right, let's find some measures of some arcs. Let's do some things with arcs right now. Postulate 10.2 is the arc addition postulate. Actually, we're just going to look at arc addition first. And that says the measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs. So just like the angle addition postulate, the segment addition postulate, if we know the measure of two adjacent arcs and you add them together, that's going to make the greater arc there. So it says find each indicated measure for circle D. Well, we've got only one arc, only one central angle here listed. But we know that semicircles make 180 degrees. So we can work with that. So GI, arc GI would be right here. Arc GI actually makes the other part of this semicircle. So it would be 180 minus 70. So that would be equal, that would be a 110 degree arc. Arc FHE. So arc FHE, FHE, it's 180. And we can use something else that we know here. Taking a look right here, we have this angle is congruent to this angle because they're vertical angles. So we have 180 for that whole one that we just had, plus that other 70 there, because this would have to be 70 as well. And that would be 250. That helps us out with some other stuff too, because if that's 70, then we know that this part, this arc right here, is 110. And these are also labeled that these are congruent, so this would be 110, or each of these halves would be 55. And we can use all of that information for the rest of it. So arc GIF, GIF, that is the major arc with everything other than the 70-degree angle. So it'd be 360 minus the 70 degrees, which is equal to 290. It's getting kind of hard to see with all my circles in here. With all my arcs drawn on here. Here's an angle, EDI. Angle EDI has to be the same measure as its essential angle, so the same measure as the arc, so that's also 70 degrees. Arc EF, we already figured that out, that's 110. And then, was there one left? Yeah, angle IDH. IDH would have to be the same as its arc measure, so it would be 55 degrees. Wonderful. So if we're dealing with something that has some variables to it says find each variable, what we can use what we know about the rest of it. So I'm just going to do letter A for you. You can try letter B on by yourself. But we know that this one is 2A minus 45, and this one is A. And that makes up a half of a circle. So that means that makes up 2A minus 45 plus A make up 180 degrees. So we can solve for A. So that would be 3A minus 45 equals 180. Add 45 to both sides. We get 3A equals 225. Divide that by 3. I believe you get 75 is equal to A. Now, you can use that to help you find the measures of those other angles. All right, the last thing we're going to cover in this video is talking about arc measures based on circumference. So we have theorem 10.9 here, which really is just called the circumference of a circle theorem, which is really just a formula that you've learned before, and it's the circumference of a circle. So the circumference of a circle is found by doing 2 times pi times a radius, or pi times the diameter. All right, that's the formula for the whole circumference. And again, the circumference is the perimeter of a circle. So how far around. All right, so using that, we have 3 examples. Not going to do all 3, but letter A, you're given the diameter is 15. So to leave an exact answers, that's without even simplifying. So for this one, the circumference would be equal to pi times the diameter, or 15 times pi, and that would be our answer. If you wanted to get the rounded answer, you can multiply it out, you get a decimal that you round. Exact answers are left in terms of pi. Now B, it gives you the radius. So the diameter would be 10.0 oh no, 11.6. So our circumference would be 11.6 times pi. All right, and you can do number C. I think you get 6.3 times pi. And these would be in not squared or anything, it's just feet or centimeters or what it would be. Now, if you're trying to find the measure of an arc, you're going to actually use the circumference. It's nothing, the measure of an arc is not supposed to be something that's challenging. Just think about it as you're taking a chunk of the circumference. And whatever fraction of the whole circle you're taking, you'd be taking that fraction of the circumference. So the theorem says the length of an arc of a circle is the product of the ratio measure of the arc over 360, so the fraction of the arc, and the circumference of the circle. So we're still finding circumference, we're just multiplying it by whatever fraction of the circle we have. So two examples. It says, what is the arc length shown for these examples? So let's find the circumference. Circumference is, and we're trying to find this arc. It might be hard to see in your notes or if you have these, but we're going to find arc, the length of arc xy. So circumference is pi times diameter, or 16 pi. And we're dealing with the central angle of 90 degrees, so we have 90-degree arc, which would be 1/4 of the circle. So 90 out of 360 is 1/4. So to find the measure of that arc, we're going to do 1/4 times 16 pi, which is 4 pi inches. So the measure of arc xy is 4 pi inches, or if you would multiply it out, 3.14, you're going to get like 13 or so inches. All right. B, we do not have the measure of the diameter, but we have a measure of a radius. So the diameter is 30, so the circumference would be 30 pi. Now to find the arc, the length of arc, we're doing xpy. So the major arc here. We're going to do whatever 240, because that's a 240-degree arc, 240 over 360. So whatever fraction that is, times 30 pi. And I'm not sure off the top of my head what 240 over 360 is. Oh, that's 2/3 of it. So that would be 2/3 of 30, which would be 20 pi centimeters. All right. And that's how you find the measure of an arc. All right. Looks like this one is you dealing with a whole semicircle, so it's going to be half of the circumference. So you're finding a fraction of the circumference. So closing questions then for this section. What is the measure of an arc? How do you find the measure of an arc? How do you find the circumference of the arc? Or of a circle, sorry. And how do you find the length of an arc? So measure is based off of what? And circumference and arc length. So that is the section on circles and arcs. The goal again was to find circumferences and measures of central angles and arcs. Have a great day.